To most of us, a wall of equations feels like an alien language, a towering, incredibly complex human invention. It's a system we spend over a decade of our lives mastering, often hunched at desks, trying to force abstract rules into our heads to pass a standardized exam. We generally assume mathematics is purely cultural. We treat it like the alphabet, a set of symbols that have to be painstakingly taught to us from scratch. But cognitive research reveals a trait called subitizing. If you look at 2 or 3 items, you don't actually count them. You instantly, automatically perceive the quantity. To find out where this ability comes from, researchers tested 6-month-old infants. The babies watch a researcher place a doll on a stage, hide it behind a screen, and add a second doll. When the screen drops to reveal an impossible outcome, like only 1 doll, a chart shows infants stare significantly longer. They recognize the discrepancy. These are 6-month-old babies. They have no vocabulary and no formal education, yet they possess a working expectation of quantity. This core number sense isn't a cultural invention, it is a biological instinct. If we possess an innate number sense, it must physically exist somewhere in our anatomy. Scans pinpoint this instinct to a very specific fold of tissue near the back of the brain, called the intraparietal sulcus. Whenever you look at a changing number of objects, this region activates. It evaluates magnitudes automatically, without you ever consciously attempting to count. This neural hardware developed for survival millions of years before humans developed algebra. In the wild, an animal needs to instantly assess whether its pack outnumbers a rival group or if a predator is approaching. Neurologists call this the approximate number system. It is highly optimized for quickly judging large relative differences, like knowing immediately that a group of 20 is larger than a group of 10. Because it's tied to basic survival, this biological number line is shared across species. Birds, fish, and mammals all rely on this same neurological system to make basic foraging decisions. We arrive in the world equipped with an internal estimator. But this biological calculator was built for the wild. It is fast, but it is fuzzy. That reliance on estimation is the hardware's inherent limitation. While it handles small groups and fast differences with ease, the system's precision begins to blur as numbers grow larger and the differences between them shrink. If you look at these 2 clusters, one containing 45 objects and the other containing 46, your brain cannot immediately tell which is larger. The innate system reaches the edge of its capability. To bypass this limitation, human societies invented number words and counting systems. They built cultural software designed to force our fuzzy hardware into exact precision. We created arbitrary visual symbols, like Arabic numerals, to act as cognitive anchors. The symbol locks an exact quantity permanently into place. When we learn to count, we physically rewire our brains. We construct new neural pathways that bridge our visual processing and language centers directly to that ancient intraparietal sulcus. This means formal mathematics is a highly advanced software patch installed deliberately over our older, approximate biological operating system. This reframes the experience of struggling in a classroom. When someone feels frustrated by fractions or algebra, they often internalize the belief that they simply aren't a math person. While individual learning styles and cognitive factors vary, the specific biological hardware for processing quantity is a universal human trait. Most of us arrive with the exact same internal equipment. The difficulty of learning math is rarely a lack of intelligence. More often, it is the natural friction of trying to link a complex, artificial language to an older, instinctual part of the brain. Even the most complex equations on Earth are built upon an accessible foundation. Mathematics is the external, structured expression of an evolutionary instinct that we are all born with.